Hello, and today's purpose of the day is I can use trig ratios to find angle measures. Please take a moment to complete the warm-up. Determine if the triangles are similar. If so, write a similarity statement. Well, first, it would be a good idea if we flipped this second triangle right here so that the two triangles actually look similar. Right now, the second one is flipped. So if I flip that triangle, it will look like this. And I have to match up the side angles, so this would be E, this would be F, and this would be D. And then the sides would also have to match up, so side ED is actually 8, side EF is 15.2, and side DF is 17.4. Now we can actually really compare these triangles because they look more like this triangle here and this triangle right here versus this one was flipped and it was a little bit hard to see which sides we would have to line up. So now if we go ahead and look at this, we can compare sides. So I would say that 17.4 would have to match up with the 43.5, and I want to see again if these side lengths are similar. So 17.4 over 43.5 simplifies to be 0.4. And if I look at side 15.2 here, that matches up with the 38. So 15.2 over 38 simplifies to be, make that a 38, simplifies to be 0.4, but it's always good to check all three sides because you never know if just one side might not be the same as the other sides. So this would be 8 over 22, which simplifies to 0.36 repeating, so all these sides are actually not similar. So these triangles are not similar, so we would not write a similarity statement, which again would match what sides which sides would match up with which sides on each triangle. So not similar. And again, that's because the sides don't simplify to be the same ratio. For a little warm-up, let's recall sine, cosine, and tangent of angles. So here if I look at the sine of angle A, what would be the two sides that measure up with sine A? Well, if you remember, we have SO, CA, TOA. So for sine, here this would be opposite over hypotenuse, which would be 15 over 17. Then we also, for cosine, have CA, C-A-H, so adjacent, which would be 8 over the hypotenuse, which would be 17, so 8 over 17. And tangent is TOA, opposite over adjacent, so opposite is 15, adjacent is 8, so 15 over 8. So again, just to recall those trig functions. So again, to test that out, just type in your calculator, sine of 30 degrees, hit enter, you'll get 0.5. So then the inverse of sine, so sine to the negative 1, which means inverse sine, of 0.5, that should equal 30. So right now on your calculator, please hit the button second sine, which will give you the inverse sine. You'll see sine to the negative first above that button on your calculator. Then type in 0.5, and you should end up with 30. So it's just a reversal. If we know a side length, we can determine an angle. Before, we were determining sides based on the angles. Now let's look at cosine. So let's try cosine of 60 degrees. What does that equal? Please type it in your calculator. You got it, 0.5. So then the inverse of cosine of 0.5, what does that equal? You got it, it equals 60. So again, the angles with the side lengths here should be matching up. So if I have tangent, let's try tangent of 45. So type in your calculator tangent of 45. That equals 1. So then the inverse of tangent of 1 equals 45 degrees. Double check those on your calculators and make sure you are getting the correct answer. So let's take some practice here finding different angles. And when we are finding an angle, we'll round to the nearest degree for angles. So sine of B equals 0.707. So in my calculator, I will type in inverse sine. So again, second sine of 0.707, and that will equal the measure of angle B. So as I will write my answer, I will say measure of angle B is equal to, and then in my calculator again, I'll type in second sine of 0.707, and I get 45 degrees. Round to the nearest degree. And I actually got 44.99, so it would round up to 45. And again, just to look at this symbol here means the measure of angle B. So M stands for measure, and then this symbol right here stands for angle. All right, let's look at cosine of angle B is equal to 0.5215. So inverse cosine of 0.5215 is equal to angle B. So the measure of angle B here, again rounded to the nearest degree, so type in your calculator second cosine of 0.5215. I got 58.56, so that rounds to 59 degrees. Now tangent of angle B is equal to 1.58, so inverse tangent of 1.58 equals B. So the measure of angle B is equal to, so my calculator second tangent of 1.58 gives me 57.66, which then would round to 58 degrees. So just some practice on finding an angle. And now we'll look at a couple examples of applying what we had just learned about inverse trig to actually solving pieces of a triangle. So let's look here at this first example. I need to find the measure of angle A, which is right here. So I'm given two side lengths. I'm given the opposite, which is 5, and the hypotenuse here, which is 6. So opposite and hypotenuse go with which trig function? You got it, sine. So I would say here, sine of angle A is equal to 5 over 6. But now I need to do the inverse trig here because I need to find the angle. So inverse sine of 5/6, again that's the side length, will equal the measure of angle A. So in my calculator I will type in second sine 5 divided by 6, round to the nearest degree, and I got 56.44, so that there would be 56 degrees, so the measure of angle A equals 56 degrees. Example number 2, again I want to find the measure of angle A because that's what I'm given here, capital A, so I'm finding that angle. So I'm given here the opposite side and the adjacent. So opposite and adjacent goes with tangent, so tangent of angle A equals 14 over 11, and it's very important that we set up our ratio correctly. So 11 over 14 would not be the same as 14 over 11. So now I need to figure out the missing angle. So inverse tangent of 14 over 11 equals the measure of angle A. And then into my calculator, I will type in second tangent of 14 over 11 and get 51.8, which then would round to 52 degrees. So the measure of angle A is 52 degrees. All right, let's look at another example. So we want to find the measure of angle A. So I am given the adjacent side and the hypotenuse, and that goes with cosine. So cosine of angle A equals adjacent over hypotenuse. So inverse cosine of 4 over 10 is equal to the measure of angle A. So in my calculator, I will type in second cosine of 4 over 10, and I get 66.4 degrees, so the measure of angle A is 66 degrees. Okay, for another example here, I need to find the measure of angle A, and I'm actually given all three sides. So here, what trig function do you think would be best to use? You got it, any function would work here. So let's set them all up and just make sure that we get the same answer. So here if I say measure of angle A, and I'll use here, let's do opposite over hypotenuse and start with sine. So sine of angle A is equal to 20 over 25. Now I'll do cosine, so adjacent, which is 15 over hypotenuse. So cosine of angle A, adjacent is 15, hypotenuse is 25. And tangent, which is opposite, 20 over adjacent 15. So tangent of angle A is equal to 20 over 15. Now go ahead and please right now take some time and find the inverse trig of all three of these examples and make sure we get the same answer. So for example, I will type in my calculator second sine of 20 over 25, and I get here 53.1, so this would be 53 degrees. I'll now type in second cosine of, so inverse cosine of 15 over 25, and I got 53.1, so that's 53 degrees. And now second tangent of 20 over 15, and I also got 53.1 degrees, so 53 degrees. Should we have gotten all the same answers? Well, yes, we should have, because we were solving for the same angle, which was angle A, and each trig function, each three of these, should really work and give the same answer if it was mathematically correct. And it is, so the measure of angle A is 53 degrees. Thank you for listening. Please see Schoology for more information. Have a great day. Bye-bye.